Hello, this is another mechanics lesson for A-level maths, year 12 A-level maths, and we're looking today at the link between displacement, velocity and acceleration. And we're going to use differentiation to do it. You might not have expected to use differentiation in these calculations, but actually it becomes incredibly useful and we use it loads and loads. So the basic idea of this is that we're going to switch between the three of them. So let's have a look at initially having using these questions. So the first two questions expect us to find the gradient of these functions at a given point. So as soon as I see gradient, I'm thinking to myself, I need to differentiate. So so get into your head that, look out for this word gradient and think, oh, is it one I need to differentiate for? And this one it is. So dy by dx, you should know, you bring down the power, gives me 12x squared, plus the bring down the power, that's 6x minus 2. And it says find the gradients at these given points. Now, of course, this is like an x and a y coordinate. And the important one is the x coordinate. I therefore say, therefore when x equals minus 1 dy by dx, and I could have written m for that instead, so in fact I'll do that, equals m. I think I prefer dy by dx for this, but I could have done that. So I substitute that in, so that gives me 12 times, and minus 1, if I square it, is 1, plus 6 times by minus 1, minus 2, what's that equal to? It's 12. I think that's 4. Okay, and I've got that right. Next one, exactly the same. Y equals this, so bring down the power to find dy by dx first of all, obviously. Bring down the power. 2 halves is a whole 1, so that's just x minus 2. Well, that's the easiest one of all. Again, sub it in the x value, so when x equals 2, dy by dx equals 2 minus 2 is 0. There you go. So what have I got? X minus 2 and m equals 0. And the next two questions ask us to use integration. So it wants us just to integrate. And you might recall that integrate is the opposite of that. Add the power divided by the power. So I'm just going to do this here. It equals, well, add a power, it's 3x cubed. So when I divide by 3, I think I just get x cubed. Plus 4x squared over 2, and I think that's 2x squared. And the minus 1 becomes minus x. Now, because this is a definite integral, it's in between two numbers, I can put that like that, 1 and 2. And then I have to substitute the 2 in. 2 cubed is 8. 2 squared is 4, but I'm doubling it, so plus another 8. Minus x is 2. So I've substituted my 2 in. I now substitute my 1 in. And I take these two answers away. So 1 cubed is 1. The great thing about 1 is it gives you 1 more or less all the time. So plus 1 squared is 1 still, so that's plus 2 when I times it by 2, minus 1. So what's that gives me? 8 plus 8 is 16, that's 14. Take away, well, I think take away 2. So I think the answer is 12. And it is 12. And the last one, it says do exactly the same thing, so I'll do it now. Square bracket, add a power, 6x cubed divided by 3. I reckon that's 2x cubed when I divide it by 3. Minus 2x squared over 2. I reckon that's minus x squared. Minus 3x. Square bracket closed, minus 2 to 2. So I need to substitute these in. So if I put 2 in, it's 2 lots of 2 cubed, which is 8. Minus 2 squared, which is 4, minus 3 2s are 6. Okay, put minus 2 in now. Well, minus 2 cubed, well, that's a minus 8, so it's 2 times by minus 8. And minus 2 squared is 4, so it's still minus 4. And minus 3x, that's minus 3 times minus 2, that's plus 6. So let's just work each bracket out. 2 8s are 16, minus 10, I reckon that's 6. Next bracket, minus 16, minus 20, I reckon minus 14, but of course it's minus and minus 14, I reckon the answer is 20. 20 is the right answer. So just a bit of a reminder there of differentiation and integration, which will be useful. Here's the link then. This is the very, very useful link. If you want velocity, it's the rate of change of displacement. Look, this rate of change is a posh way of saying differentiate. So we'll see that in a bit, but the idea of this, if I differentiate x, because it says the rate of change of the displacement, so I'm going to write dx, and you always do it over with respect to time, so dx by dt equals v is basically my rule. And I suppose really what I'm doing is I'm saying displacement is always going to be written with an x, velocity is always going to be written with a v, and acceleration will always be written with an a. And that's why I can say velocity, which is v, is the rate of change of the displacement. Dx by dt is v. Acceleration, a, is the rate of change of velocity. So said a different way, if I rate of change again, notice that if I differentiate the velocity with respect to time, that will give me the acceleration. And so that is what I've just said. Put another way, we can say that v is dx by dt and a is dv by dt. Write these down. It's very, very important that you know that if you differentiate the displacement, you'll get the velocity. If you differentiate the velocity, you'll get the acceleration. Now, some of these can be written like this. Now, I quite like writing next to these x, v, a. Remember xva, 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 but when you go down this list, you differentiate. And I quite like the fact that if I go down that list, I differentiate. And it implies, perhaps later on we'll think about what happens if I go up this list. But for today's lesson, we're only going down the list. So if I differentiate x, I get v. If I differentiate v, I get a. And we don't often have to differentiate the a. An example of this question then. A motorist drives her car along a straight road. There she is driving her car. It looks like a very posh sports car. Displacement x meters from a is given by this equation. Now ignore this t. T just tells you it's the variable. So effectively it's just saying x equals 0.04 t cubed plus 0.1 t squared. That's what I take that to be. Where t seconds is the time after leaving A. Okay, find the velocity when t equals 10. Okay, so all I do is substitute 10 into the velocity equation. But notice, if I'm not careful, I'm going to sub it into the wrong equation. I need, first of all, to get v. But luckily, I've got an equation. It says v is dx by dt. So I differentiate this equation and bring the 3 down to the front. It gives me a times, and that gives me, I think, 0.12, and then lose a power, t squared. Then do the same for this one. Bring the 2 down to the front. That gives me 0.2 t, and then I'll lose a power, which is 1, which is that done. Therefore, when t equals 10, what do I reckon v equals? Well, it's manual 1, so it's 0.12 times what is effectively 100, 10 squared, plus 0.2 times by t, which is 10. And that's 14. Could have done that in your head. And B, find the acceleration. Alright, now I need the acceleration. A is dv by dt. So having differentiated it once to get the v, I now differentiate it again to get the a. Bring the 2 to the front. It's getting easier because there's less terms. 0.24 t. And this just becomes plus 0.2. So, and it says when t equals 20. So, when t equals 20. So I substitute 20 into this. So 0.24 times 20 plus 0.2. And I get exactly 5. A equals 5. Good. There you go. And that's me written in function notation, but that's the right answers. Question now. The displacement of a particle is given by, from a point which we've called the origin, O. To be honest, it doesn't really matter, but O is, you think of that as being the starting position, the original point. So it's given by this equation, x equals 0.03 t cubed minus 0.18 t squared. Find expressions for the velocity and acceleration. Well, easy. V is dx by dt. We differentiate. So bring the 3 to the front, 0.09 t squared. Minus, bring the 2 to the front, 0.36 t. lost a power, there's only one left. That's the v equals, and the a equals, I differentiate dv by dt. So now you look at this one and differentiate 0.18 t minus 0.36. Excellent. So that's part A done. So part B, what does part B say? It says, for what values of t is the particle at rest? Well, at rest is a posh way of saying v equals 0. So which one is v? V is this. So therefore, 0.09 t squared minus 0.36 t equals 0. Now you could use your posh button on your calculator to solve this. I reckon I can just factorise it with one single bracket. 0.09 goes into both of them, and t goes into both as well. And when I factorise, I think I get t minus 4 equals 0. So either this is equal to 0, which means t equals 0, because 0.09 t equals 0, and therefore divide nothing by 0.09, you get t equals 0. And this one tells me that t equals 4. And I think what values of t? Oh, it does want both answers, so I think I get two answers, t equals 0 and t equals 4. T equals 0 and t equals 4, and I'll presume they've got those right as well. The train is travelling along a straight track, velocity equals, so notice this time they've given me the v equals equation, the v. So it says, what's the initial speed of the train? Oh, this is great when they ask for initial speed. It comes up loads actually. Initial speed is when t equals 0. So that's a t equals 0, therefore, this is part A. Therefore, v equals 0.01 times 0 squared minus 0.05. 0.5 times 0 plus 7. You'll notice the only thing that matters is that 7, because everything else disappears. So I think the first answer is 7. B. Find the time when the train has 0 acceleration. Well, I haven't got an expression for the acceleration yet. I get it by differentiation. A equals dv by dt. So let's differentiate it. Bring the 2 to the front. That's 0.02 t minus 0.5. The t disappears and everything else disappears. When is that equal to, has 0 acceleration? Well, that's when it's equal to 0. So let's solve this equation. 0.02 t therefore equals 0.5. Just by moving that over. Divide by the 0.02 is 0.5. Divided by the 0.02. So just type it into my calculator. 0.5 divided by 0.02. And I get 25. So after 25 seconds, this train has stopped accelerating. What happens after that, who knows? But 25 seconds and 7 meters per second for the first one. Look, that's it. That's us done. That's exercise 19C.1. We actually come back to this exercise again, and 19C.2 will be to do exactly the same thing but use integration. So that's why I'm saying to you, have a look at certain questions. There might be others that we can do as well, but these ones definitely are okay. These are all going to use differentiation, and some of the other questions will use integration instead, and we'll see that in a separate PowerPoint lesson video. So all the best. Thank you very much.